Hello, ladies and gentlemen. This is Mr. Sanford, and we're going to go through some notes where we talk about determining limiting and excess reactants based on particle models. So we've got example problem 1 here. We're going to determine the number of moles of water that can be created when 6 moles of hydrogen gas, which is H2, are reacted with 2 moles of oxygen gas, O2, according to the balanced chemical equation below. So you've got your balanced equation here. And what I'd like to point out are the coefficients that are on each of these compounds. So 2 for hydrogen, 1 for oxygen, and 2 for H2O. So the question prompt tells us that we start with 6 moles of hydrogen gas. So the reactants part of this is going to start with 6 molecules of hydrogen gas. So 1, 2, 3, 4, 5, 6, they're all there. And we're also going to start with 2 moles of oxygen gas. So these are the darker circles, the oxygen gas, according to our key down here. And so notice that we can, for every 1 oxygen and 2 hydrogens, we'll be able to create 2 water molecules. So if we highlight 1 oxygen molecule and 2 hydrogen molecules, that tells us that we should be able to create, according to our coefficients, 1 oxygen and 2 hydrogens, we should be able to create 2 water molecules. So we get them there. And then we have another set that we can highlight as well. This set here, 1 oxygen molecule and 2 hydrogens. Our coefficients, according to this ratio, tell us we can create 2 more water molecules. So they appear on the product side. But we didn't use everything. So there are these 2 leftover reactants. So 2 molecules of hydrogen left over as well. And so once we get our particle models drawn, we will want to do the analysis. So we need to figure out which reactant is limiting in the reaction. So which one gets completely used up and which one determines how much product is actually made. So that would be the oxygen molecules, right? So all of the oxygen molecules got used up, right? There were 4 oxygen atoms, and they're all 4 appear here. So the oxygen is the limiting reactant. The excess reactant, we know from our definitions that we just learned, that excess means that there's leftover after the reaction goes to completion. So because there are leftover hydrogens, we would call that our excess reactant, and it asks for an explanation. So we would say something like all of the O2 was used and some of the H2 was left over. And then finally, how many moles of excess reactant are left? We would want to count up the moles. So each particle here in our particle model represents a mole. So there are 2 particles of hydrogen left, so we would say 2 moles. Let's do another example together. So this question gives you a different reaction. It asks you to determine the number of moles of ammonia, NH3, that can be created from 6 moles of hydrogen gas, H2, and 3 moles of nitrogen gas, according to the balanced chemical equation below. So we have our balanced chemical equation, and again, our coefficients are going to help us out tremendously here. So 1 on the nitrogen, 3 on the hydrogen, and 2 on ammonia. So we have our 6 moles of hydrogen gas, right? The white circles represent the hydrogen, and our 3 moles of nitrogen gas, those are going to be the gray ones. So according to our ratio here, 1 nitrogen, 3 hydrogens should make 2 ammonias. So if we highlight that, 1 nitrogen and 3 hydrogens, that should give us 2 ammonias. And there's another grouping we can make with 1 nitrogen and 3 hydrogens. That should give us 2 more ammonias. And then we have this single guy left over right here. So now that we've drawn our particles, we can do the analysis and figure out the limiting excess and how much excess. So which is the limiting reactant in this reaction? So which one ran out first? Which one did we not have any leftovers for? So if you look, there are no leftover white circles, which is the hydrogen. So the hydrogen this time is the limiting reactant. There were none left over. The number of hydrogen moles determined how much product we could make. Which is the excess in this reaction? This would be the one with leftovers. So here we would have our nitrogen as excess. An explanation could be all hydrogens were used and only some of the nitrogens were used, and so there was some left over. So how many left over? How many moles? Well, we look at the number of particles that represent N2, and we have 1 mole there.